Good morning. I'm at the Bald Bluff State Natural Area outside of Palmyra in, I think we're in Waukesha County. This is a site that has a lot of interesting habitat differentiation. So in not a lot of walking from here, we can get into quite a few different habitat types. So I think I want to survey those and kind of show you the differences in the plant communities there and kind of overlay a map of the site and get you an idea of what's going on here. And just an appreciation, I think, for the fact that habitats can be very diverse in a small amount of area. So I'll start you off in the open area there. This is a road called Young Road, and that's the access point I usually use. This is where the Ice Age Trail crosses. And right now there's another crossing. So you can see above us there's some power lines. So this is an area called a right-of-way where the people who maintain the power lines, they keep this area clear. So they deliberately cut out trees and such that might be growing through here, and they keep a continuous path for the power lines and the structures that bear the power lines, and it just kind of long-term make sure that the trees don't grow up and around the structures that people need to access if they ever need to get up on those power lines. And this year, actually, we've got some nice evidence that there's been some management in this area. These look like the result of some chemical herbicide. I know that we have, I did a closer inspection, we have some plants that are kind of abundant and maybe encroaching on this open habitat here. These in the foreground are sumacs, pretty prolific plant. We do have some that they left alone over off to the side. And then those look like maybe aspens, I think. So I think they've deliberately sprayed those, and they're trying to keep the other communities intact. So this is a cross of several functions also. So we have state natural area, but then also the power lines. And so the power lines, of course, have probably a priority to operate here, but they can operate along with maintaining the state natural area. But kind of interestingly, because of needing to keep the trees out of this area, this was preserving a habitat here that might not otherwise get the attention, the maintenance that would keep it that way. So let's just, from this position, glance over at the different habitat types we can see. On either side of me, really, there are wooded areas. So you can see more trees coming in. I see some members of the red oak group in this area. Looks like probably some bur oaks as well. So red oaks and bur oaks. Off to beyond where my car is a nice wooded area, much different community. Maybe a little bit of overlap with this wooded area over here. And then there's a topographic feature. I don't know if you can see how well that is uphill. There's an interesting just open area on this rounded hill here. And that's where I find, when I explore this site, some of the most, I'd say, most rare plants on the site. We'll show you some of those. So just a quick overview, and then we'll get in and look at the individual habitats and the species that can be found there. So we're in the power line right of way now. This is the open habitat, and you can see a lot of grasses or graminoids in this area. Not all of them are going to be identifiable. There's one that kind of stands out here. This is a grass called dicanthelium, and it's got, try to focus that. It's got separate and rather fat flowers that are developing into those grain inflorescences. Also pretty substantial leaf blades, so quite broad, and hairy on the leaf sheaths there. So pretty hairy, pretty broad leaves. Dicanthelium is a genus that we have quite a few species in, but this happens to be one of them, and it's kind of a short stature grass, but as grasses go, some of the bigger, maybe really big leaf blades relative to the size of these plants. So they don't get much taller than my hand here. But they've got blades as wide as grasses much larger than themselves. A handful of these are in here. This is a member of the sunflower family called goat's beard Tragopogon. This is a couple of the sumacs. I don't know, it looks like they might have hit this one deliberately. So normally looking a little bit better. I'll show you some intact sumacs in a little bit here. So I backtracked just a little bit. We're up on a hillside a little bit away from the right-of-way. In here are some sumacs. So these are smooth sumac, Rus glabra. We don't have a whole lot in the genus Rus, and this is one you can basically tell the big species that you're likely to find based on whether they are fuzzy on this part of the stem, or this is a plant that is male or female plants. We got flowers that haven't quite opened here, and I don't see any in the area that open. This is a good pioneer species. It's often found on roadsides, and its pioneer properties are what's causing people to try to keep it out of that right of way. Also kind of interesting, there's like a little community in here. So we've got some roses in here. That's the native rose, nice big flowers. My finger's in there for scale, so very big relative to the multiflora rose we've seen a little bit before. Here we've got a daisy fleabane in the sunflower family, and it's overcast and a little bit just slightly raining today, so that looks like maybe a good reason that this animal is not all that active. Warm but wet, so maybe not feeling it right now. So some more of this habitat. This is looking rather even without the plants that they're trying to spray with the herbicides, so maybe a little better reflection of what would be here as a natural community. So we still have that dicanthelium grass in here. Here's some reproductive parts of that. Quite a few grasses. I don't know if I have names for all these just yet. Have to get back in there. So not a lot in flower. Some of these habitats we might have to come back and visit again. Check my list for what's here. But here's one that definitely catches the eye. It's kind of similar to, we have plants called evening primrose, might kind of look like those. Those have four petals instead of 5. It's got the common name of rock rose, plants in this group, and it does look kind of rosy. So 5 petals, rose family anyway, 5 petals, lots of stamens, but it does have a fused gynecium, so the ovary is fused to several carpels here. Belongs to a group we don't have a lot of species in. This is the rock rose family called Cistaceae. And a handful of these. The flowers on this one are terribly short-lived, so kind of lucky that we're catching one that's open to look at right now. You can kind of see ecologically a few of these grass tussocks, so sort of a clump of grass, possibly related all at the same, maybe clones of the same plant that's branching out from this location. But that area is raised up above the ground a little bit just by virtue of having a few planted individuals grow there. So we're actually under the one of the towers for the power lines, and just in this location I happen to notice quite a few species that are worth mentioning. So I don't know if they're standing out super well from the background. This is one of this is the wild asparagus. This is actually the same species as you would buy as grocery store asparagus. It's not native, and this is what happens. You might be familiar with the asparagus spears you buy in the grocery store. This is what happens when it grows out, if you didn't have this already growing in your garden. This is a monocot, and the flowers looks like they're not opening. This plant looks like it got herbicided as well, so might not actually end up opening these flowers. But if you open the flowers, you would see they have 6 perianth parts, telling you that we've got a multiple of 3, probably a monocot, and indeed it is a monocot. Just a few of the individuals of the species in this area. The understory, going down a little bit lower, we've got a sedge here. So sedge, again, genus Carex, has those fruits in this sort of teardrop shape enclosure. So if you separate them out individually, that's what they look like. The flowers typically aren't part of what you use to identify them, although sometimes the stigma lobes stick around and you can count those and use that to identify. Just overall, there's some differences in how these spikelets are put together. So these are kind of squished down a little bit, sort of squat, fat clusters of, I don't know, 20 20 flowers in there. So we'll get an ID on this one for the video. One of our Carex species. One of our weedy species in this habitat is a member of the mustard family. It doesn't necessarily look immediately like a member of the mustard family. So mustard have 4 petals in their flowers. And let's see if we can get one of these isolated. Everything's small. All right, hold on. There we go. All right, here we really go. All right, so you might have to trust me on this one. Okay, so we have 4 petals, but each petal is cut very deeply. So on the bottom here, I got 4 fringes belonging to 2 petals. On the top, I've got 4 fringes belonging to 2 petals. I was lucky to get it arranged this way, so I don't know if I'll take it apart some more. That cutting of the petals, that's something we typically see in the carnation family, Caryophyllaceae, but indeed having 4 petals puts this more in the mustard family, as would some other characteristics. So carnation family, we would expect opposite leaves. This one has alternate leaves. The inflorescence kind of modeled on a raceme, kind of still early season for this one. And fuzzy along the stem, that gives it its common name, the hoary alyssum, Bergeroa incana. And a handful of these around, not too many in this local habitat. And then just maybe call a little attention to part of this habitat on the substrate here. So we've got a very rocky substrate. I don't often comment on what's underfoot, but this is just sandy, some actual visible rocks. The growing of these, I'm just going to call them lichen. So that's a moss there. So moss pretty well dried out in this area, taking advantage of a habitat where it can grow nicely. Kind of telling us we've got a little bit of a different habitat here. So we're heading down the east-facing slope, still in the right-of-way. We picked up a little bit of a little more shaded area. So here we are, not too far away from some hickory in the foreground, oak off to the left side there. And a lot of what's growing in this area is this, well, noticeable anyway. We've got a little scrambling vine here. This is a stem twining vine. So you can see it's twisting around the stem of this, dead stem of this plant from last year. We have simple leaves, parallel venation, a little bit serrate on the margins. Alternate, did I say that? Alternate. This is a plant called bittersweet in the genus Celastris in the family Celastraceae. Also in here, maybe worth noting, we've got some seedlings of hickory, so not too surprising. We have adult hickory up in the forest layer. Hickory seedlings would definitely be reasonable to expect in here. Some plants, might expect this one to be flowering on an ordinary day, but it's just not very sunny today. So this is our blue jacket spiderwort, Tradescantia ohiensis. Not too many of these. These are kind of occasional in this habitat. Common milkweed, opposite leaves. You get to recognize common milkweed pretty easily. Milky sap coming out as I break the leaf there. Also suffering still a little bit from that herbicide. You can see we've got just a good number of plants that have been hit with the herbicide. So we made it down to the bottom of this valley, and then we're heading up the other side. This is kind of a more of a south-facing hillside, and I just wanted to point out that the grasses are holding their little tussocks together, and in between them lots of bare sand. So sand is often a sign of an area that's maybe nutrient poor. Sand is not very organic, and organic areas would hold on to nutrients a little bit better. Also, sand drains a little bit better, so this would be an area that maybe dries out more, and plants would have to be adapted to hold on to their water a little bit better. So definitely some signs that this should be a different kind of habitat than just your average open prairie kind of situation. So I want to walk you through a habitat transition here. We're going to head up to the exposed hilltop there where some interesting plants grow. But to start with, we're in the right-of-way open habitat now. Here's our herbicided aspen trees in the foreground. There's a little bit of a transition, kind of an edge zone here that we're going to walk through. I'll show you some plants in there. Off to the side, we've got an oak. Looks like I'll go bur oak on that one. Over here, foreground that tree is a cherry. Then we've got another bur oak over there. So bur oaks are one of the characteristic species of the original habitats in this location. Things have changed now that the herbivore pressure is gone. The fires have not been as frequent as they were prehistorically, pre-settlement. All right, so I'll identify some that I can tell in here. I can't tell you what everything is, so we don't have flowers on everything. We got a goldenrod, probably our common Canada goldenrod. This one here we've seen before at Bluff Creek. So opposite leaves with these, honestly, I think of a cherry when I see that leaf, but cherries would not have opposite leaves. So this would be viburnum, that nannyberry viburnum lentago species. Here's another sumac, another smooth sumac. Big, long, pinnately compound leaves with serrate, pretty deep teeth, serrate margins there. And then some you can see flowering occasionally. Kind of a shrub layer coming up here. So within that, you often find some scrambling plants. This is a woodbine Parthenocyssus. And that's got some tip of one there with some tendrils coming out. I've got some bramble that looks like maybe a black raspberry, genus Rubus. There's a handful of these herbaceous anemone plants. So anemone whorls of leaves kind of right under the inflorescence. Usually threes, but it looks like we got 4 going on here. This is kind of a complex branching that's going on. So it's a lot of leaves branching off here at the top of an otherwise naked stem. Whorl of, looks like we're technically compound for at least a couple of these. And then flower buds at the top. This will make a couple flowers before the season's over. So that's probably a tall thimbleweed. There's some Achillea here. So yarrow. What else have we got? We got some aspen. So this would be related to the seedlings that they have sprayed with the herbicide over there. And maybe continue through, seeing a lot of the same. This one looks like maybe a sunflower. I don't have a good name for it right now. Moving through, pushing through. Here's some more of that bittersweet. So we just kind of tell based on this branch heading off to the side. This is maybe not supporting itself all the way. It just has kind of a, maybe too long to be part of a shrub this high off the ground. Here's much better evidence. So this is the tip of one of those. So growing in some leaves as we go. This would be just the very growing tip. And as that goes up, it's supporting itself, but it's really kind of searching for something to grab onto. Little does it know, not really any trees in this immediate area. Bittersweet there. Technical name, bittersweet. All right, heading up through. Wish we had more reproductive structures on here. All right, and then we've gotten into, as I look ahead of me about 5 feet, the shrubs are really decreasing in their abundance. So it's really like I went through a brief transition zone, and then we start to pick up some of the plants I'll show you starting in the next video here. So kind of a special plant there, kind of a rare plant down here, and we'll highlight those in a second. All right, so really neat habitat just like immediately after getting into this area. Probably easiest to notice the pretty flowers to begin with. This is a lobelia plant. Lobelia has oops, hold still, Lobelia. Has fused petals, and they do 3 low and 2 high, so it's 5 is the petal number really to start with. One thing that I think of with these, they have kind of a sharp look on their petals. If you got in there a little more carefully, you'd see they have an interesting arrangement of stamens around the gynoecium there. A handful of Lobelia species found in the state. So this is one of them. Not a lot of flowers along the stem here. Just a few. They are elliptic with toothy margins and kind of all the way down, not a big basal cluster of leaves. Another one, this one has moved on from flowers into doing fruiting right about now. This is the alum root. Genus is Heuchera. And this one has a flower stalk without leaves, heading down to these kinds of leaves are coming from its base. So big basal lobes, palmate venation, kind of a deep toothy margin, very fuzzy petioles on those leaves, fuzzy stem. There it is. Other ones, this one is past its time by quite a bit. This is one of the earliest ones we see. I'd recommend, if I don't show you one, just look up, this is has a funny name, common name, the hoary puccoon, Lithospermum canescens. One of our earliest flowering species, high coefficient of conservatism. It has an interesting inflorescence that kind of unravels over time, unrolls. So this is thoroughly unrolled, and its fruits are these little nutlets. So Lithospermum, scientific name means stone seed. And so they're really rocks, like tough, hard achenes. They're actually achenes that break apart from a starting fruit. I'm going to take a guess on this one. I think this might be the shining aster, Aster sericea. Sorry, Symphiatricum sericium. And that would be one, if it is this species, this one will actually produce flowers later in the year. So we've seen a lot of plants that are done flowering, and this one is not yet flowering. So we've got some rare plants and also some encroachment. So every habitat can be habitats can be quite pristine, but they also would sort of be under pressure from whatever's around them. So we have here a black locust sapling coming up. This is Robinia pseudacacia. This is one that is actually native to North America, but not native to our area. So it's sort of exceeding its range at this moment, becoming problematic in places. One thing to watch out for, so we have bean family kind of leaves, pinnately compound entire margins, kind of a smooth look overall, swollen stalks on those leaflets. And then the black locust has pretty substantial spines associated with about where the stipules would be. Some other troublesome plants in here. This is a sweet clover, Melolotus. Just a handful of those in here. So kind of creeping into a part of the habitat that's otherwise pretty full of rare plants. One of our most special plants in this area is a monocot. You can tell by the 6 perianth parts there. Let's check the back there. So those would be no special sepals on the back. So these would be 6 tepals showing there. And getting totally rained on right now. And we're back. So this plant again, this is a monocot. We can see that we've got the 6 tepals right there. I can also see if we look at the leaves. So the individual leaves down at the base here, these are linear leaves coming from the base of that same plant. And let's get into some more detail on one of the flowers. So flower with a bract at its base, that's pretty common, so kind of a specialized leaf. Right where the pedicel leaves the stem, we've got flowers with pedicels all along the inflorescence, which is terminal. So the only thing coming up as a stem is this flower stalk, and would count as a raceme. So no branching within the inflorescence. I'll take one of these off and get in a little more detail there. So we've got the 6 petals. And if you want to find out what's going on, it's important to dissect these apart. I recommend kind of a fingernail dissection longitudinally. If you're going to do anything, that's maybe the best thing to dissect there. So you can see, looks like we've got a little bit of fusion. So off to the side, you can see these stamens are kind of attached to the petals, tepals, and then the tepals themselves attach right about where my fingernail is there. So the receptacle, the really bottom of the flower, is lower down than the attachment point where these organs meet each other. Can also kind of peel this away, and you can see that the stamens come with the tepals. That's a good way to see that they're fused. So counting those, we had 6 stamens. That's pretty common for stamens to be a multiple of the perianth. And then also, if we peel more away here, we can get into the specifics of the gynecium there, the female organs. So it doesn't really want to give itself up just yet. All right, I'm just going to hold the stamens out of the way. And we can see that we've got a 3-parted stigma there. So fused gynecium, 3 carpels fused together to make that up. And then the ovary down there, and I've cut it when I did the dissection. You can see it's kind of mealy in there. Those mealy bits are the ovules. Those are what will become fertilized to become the seeds. So a little more detail on the flower of this one. And this one is a rare plant, and one to watch out for. It's got a very interesting common name, the death camas. So you can maybe guess why you'd want to avoid this one. Nothing to worry about for brushing up against it. But if you just happen to eat a random plant in the field, this one would treat you pretty badly. So we're up on the sunny hillside of Bald Bluff, and I just want to point out a few that are kind of abundant in here. I don't see flowers on them just yet. This is still kind of late June, and this is one that there are a few plants that kind of look like this one. So just an upright plant with linear leaves kind of going together up along the stalk of that. You can see there's just a bit of a flower, actually inflorescence bud kind of going here. This is early season for a lot of plants still. And so we have some milkweeds that kind of look like this superficially. We've got some members of the sunflower family that look like this. And this one happens to be a member of the bean family, kind of an unconventional look to the bean family. This is a plant called prairie clover in the genus Dahlia. We can see that it's got some stipules down at the leaf base, and then see that this leaf is in fact compound. So it's hard sometimes to remember that these are compound leaves on first appearance. So it's good to get in there and take them apart and double check that. Another member of the bean family, I don't think I can put a name on this just yet, but another one of these viney bean plants, bean family plants, I should say, so probably a vetch or vetchling. Pinnately compound leaves terminating in a tendril, and the tendril's grabbing onto this dead stem from last year. No flowers on that just yet. Next to this, we've got an aspen. I think I've shown you this one before. So pretty distinctive leaves on the aspen, sometimes mistaken for or similar to our cottonwoods, things like that. So aspens have some relatives that sometimes look quite a bit like them. I think we're pretty safe to call this an aspen. It has more of a kind of a rounded triangle look to the leaf. And then to place it in the genus, we've got a lot of these with the flattened petiole. It helps those leaves to flap around in the wind a little bit. Near us, we've also got a sumac, another smooth sumac here. Dogwood, we can see we've got opposite leaves. Pull those apart. dogwood test, so one of our dogwood species there. And then a little bit of leftovers for an early flowering plant in here. This is a shooting star. Used to be in a genus called Dodecatheon, and now it's in a genus Primula, family Primulaceae, the shooting star. So here's a good chance to contrast a couple of closely related species. These would be in the same genus called Populus in the willow family, Salicaceae. This is the aspen that I showed you just not long ago. And then this is one, I think I want to call it maybe a big tooth aspen. So much more deeply toothed on the margins, larger leaves overall. Still lots of similarities, so overall leaf shape is similar, flattened petiole is similar. Tells us that we've got this in the same genus, Populus. And then what really stood out to me about this one is that the new growth is like waxy fuzzy. And that's something I wasn't seeing on the aspen. So they're the quaking aspen, I should say. So I want to initially call this big tooth aspen. I can check this moving forward. So here's a nice one with some big showy flowers. This is a plant called harebell in the bellflower family, Campanulaceae. And the flowers are pretty hard to miss. The vegetative parts would be maybe easier to miss. So it has a little bit uncharacteristically for this group, very linear leaves. It is a dicot. You might start thinking monocot to see leaves looking so grass-like. We can get in and take one of these flowers apart. So the inflorescence, I think I would qualify that as a raceme. So just a single stalk with single flowers coming off. They have pedicels each. And I will take one of these apart to talk about it. Hey, look at that, I learned something new. So this is milky sap. I did not expect that. Not a group I typically think of as having milky sap, so wasn't ready for that one. All right, so we have down at the base some, again, rather linear sepals. The petals are fused together and 5 in number. And Campanulaceae does a weird thing. Oh, sorry, friend. There was a bee sleeping in there. So big open flowers like this are sometimes good shelter. So it's kind of it was rainy yesterday, kind of a cool morning. This is not a bad day to chill out inside of a flower if you want to. Okay, so back to the flower. So this group has, it's related to the sunflower group. This is a nice large flower example of what I'm going to show you. The sunflowers also do this, but their individual flowers are much smaller. It's what we call secondary pollen presentation. So down around this area, these are basically spent anthers. And as this flower was developing, those anthers were kind of grouped up around the style, and the style grew through them. And there actually is pollen on the outside here, kind of the underside, what will be the underside of the stigma. So the female reproductive structure actually picks up pollen to distribute, not to receive. Then later, this top part is going to open up, and that's going to expose the receiving stigma. But at the moment, this is the kind of the sending part. So a little bit weird if you're not ready to understand what's going on there, but pretty cool nonetheless. Let's see if we can get in for the ovary. Looks like ovary is there's some attachment of the petals to the ovary. And probably the best way is to, again, dissect this. If you can dissect it with a sharp instrument, that's better, but in the field I find fingernails are pretty good. All right, so that ovary with the, again, kind of grainy looking ovules was inferior, I'm going to say. So the sepals I can feel are attached to the ovary, petals kind of attached to the ovary. So that makes it an inferior ovary. So here's one I don't know if I've seen before. This definitely stood out to me as a bright color in among some grasses and sedges around me. Really small though. So this is my finger. There's the flower, raceme. Individual flowers. A little hard to see what's going on. Let's see if we can take one of these apart. And okay, individual flower. So it just kind of looks like it's all wrapped up in a kind of a uniform ball, but there's more going on here. So if I take it apart, there's a couple of petals that go off to the side, and then there's like a fringy bottom petal. I think I'm going to push the limits of what my camera can do here. So two side petals and then one petal that's kind of fringy in between them, and then there are more petals besides. You can also see a sepal on there. I don't think I'm going to have success dissecting this. This is a group of plants called Polygala, the milkworts, and we'll get an identification on that. Not too many of those. Maybe I'll consult the key and see what it says about helping me to identify this particular species. Other milkworts that I'm aware of have larger flowers. This one is really, really tiny. So a few people have submitted phytography forms with plants in this group. This is the sunflower family. There is a presentation on plants in the sunflower family, and a lot of people were not using the terminology correctly, so I'm going to walk you through maybe a couple of these as we go today. Sunflower family plants have what you call pseudo flowers, or basically an inflorescence group that looks like a flower. So this is, the technical name is a capitulum. It is a lot of flowers. So around the outside are flowers with white petals, and along the inside are flowers with yellow petals. And the flowers on the inside, we call that the disc. So the inside of these flowers, if it's present, we call it a disc, and it's made up of lots of flowers in kind of a spiral pattern. So this is the sunflower family. You might be familiar with sunflowers, a nice large example there of the same stuff that I'm talking about here. And to understand what's going on, we really got to take these apart, just like with everything else. Down at the base, there are some specialized bracts, green parts here called filaries. So they're not technically sepals, but they kind of look like sepals. So really, you'd be forgiven as a novice for thinking of this as a flower. But that's one of the big challenges of moving forward in getting good as a botanist, is avoiding the urge to call this a flower. This is actually an inflorescence or a group of flowers. Or if you want a shorthand, you could just call it a flower head. So I'm going to dissect this like I was dissecting a normal flower. We'll already see that there's different stuff going on here. So rather than spilling out stamens and carpels, I'm breaking this up, and a whole bunch of individual flowers are coming out. So those are some individual flowers have the white long petals. Lots of individual flowers are smaller with yellow petals. The yellow petaled ones really do the heavy lifting as far as reproduction. Each of those is a flower. After fertilization, those develop into single fruits. So those would be nut fruits or achenes. And so reproducing a fruiting version of one of these would be have a head full of achenes. As far as getting into the specifics of any one of those flowers, I definitely don't have the power to do that with my camera here. But each of those yellow petaled flowers would have stamens, would have an ovary. Technically in here there are sepals. I don't think you'll be able to make those out, but they're like a fringed covering around the base of these flowers. So I'd recommend maybe consulting a photograph that somebody's taken at better resolution, higher magnification, to tell you what's going on with these. As with a lot of the diverse groups that we have, really to identify these groups responsibly, you've got to get in there, take them apart, use your hand lens, and then be familiar with all the terminology that's required to talk about these. Here are some flowers open on this smooth sumac, so we can get in there and explore. And I really think like 90% of getting comfortable identifying plants is being willing to look small. So things are just at the small level. So this is a multiple branched panicle inflorescence here. And some of the flowers are open, lots of them are still there as buds. Individual flowers have pedicels. And this group is dioecious. So this would be, take a guess, male or female, a male flower. So you can see the stamens on there. 5, 1, 2, 3, 4, 5 anthers matching the 1, 2, 3, 4, 5 petals. And then if we get into greater detail, not really an ovary to speak of. So this flower, and it turns out this whole plant is devoted to giving pollen and not receiving pollen. So I've gone looking for female versions of the smooth sumac. I'm not finding them, and I think that's a good occasion to tell you something else about the sumacs here, is that they reproduce clonally. So a lot of times you'll see a group of sumacs. This is a common roadside plant. You'll see lots of them together, and what you see are potentially really just copies of the same plant copied underground. So they're spreading by runners underground. And if you have a plant that is dioecious, that means that a male plant is going to make another male plant, is going to make another male plant, and so on. So you can kind of identify in this species members that are probably all the same genetic individual, even though they're fairly widespread here. Members of the same species, the same genetic individual, reproduced by cloning, and therefore all male. Now this is actually maybe kind of ties in with the reason why it's good to be dioecious, is that all these plants that are related to each other, very genetically similar, actually should not probably be reproducing with themselves, and it turns out that they can't, right? So that they can't have two clones that are genetically identical. They can't make a seed together because they're only producing pollen. So that's kind of a handy upshot to being dioecious. I see some pollinators in here, so let's just tack this onto the video. Lots of flower visitors going on. Just love watching flower visitors. So we've got one of our bees, looks like. Good diversity of bees. Honeybees are not native, but we have lots of native bees. You can see big fuzzy yellow patches on its back legs. This bee has packed pollen onto there. So bees forage for nectar and also pollen. Pollen is a food source for developing baby bees, and the nectar is a little more of a short-term energy source. Here we've got, oh good, so 3 individuals here. Left, top left is a hoverfly. Bottom is another kind of fly. Flies have, to me, more proportionally giant eyes. So they're compound eyes, but in the flies, those compound eyes really just fill the head. Not so much in the bees and wasps. You can see in that hoverfly, it's doing some slurping. So possibly in there looking for nectar. Oh, really good. Good day to capture this stuff. So it's overcast, it's a cool morning. It's about 9:30 in the morning. And a good time for these animals to be active. When the world is warm enough, but not too warm. Morning and evening are active times for pollinators usually. All right, so we've headed away from the hill. We're moving into a more shaded area. And a couple, so you can see that the shrub layer has really thickened up in here. We don't have the grass or graminoid cover that we had on the exposed area. A couple species can show you here. One that's nicely in flower. So we have a monocot here. So parallel veins, sessile leaves, and at first blush, no flowers, but wait, there they are. So these are pendant flowers. They hang down, and this has an interesting, I guess, scientific and common name. So the common name is Solomon's seal. Get that name. The Solomon's seal is otherwise known as the Star of David or the six-pointed star. And that refers to the flowers. We've kind of spent our flowers already, so these are perianth parts that are kind of shriveling up right now. But you can see there's a pretty big ovary developing into a fruit right there. You can see the attachment points where the perianth was attached. So this would make this a superior ovary. And I can pull that off and show you the fruit developing a little bit more. Scientific name, Polygonatum biflorum, which I find interesting. Other places I've seen this plant, it does have 2 flowers at a time. In our region, typically more than 2. So you can see 3 flower stalks there coming from the node of this leaf and just kind of hanging down from individual nodes along the stem. So that's the Solomon's seal. This other one gets the name of false Solomon's seal, one of its common names. So this has similar leaves, parallel venation, similar shape, also sessile, also alternate, but its inflorescence is a terminal panicle here, also similarly timed with the flowering. So this one also has some spent perianth parts and then developing into fruits, berries. So this is kind of another kind of I'd say misapplied scientific name. Unfortunately, we don't get to update scientific names. So this one gets called Myanthemum racemosum. Racemose is based on raceme, and of course we have a panicle to the racemed false Solomon seal. So 2 that look alike, worth knowing from each other. Without flowers, they are pretty hard to tell apart. With flowers, much easier. So we've got lots of variation in this big genus Carex, one of our graminoids. These get called sedge with their common name. And as we've seen before, so the periginium, the tissue covering the ovaries, there's sort of a papery cover around the ovary, pretty standard teardrop shape to the ovary. And then this one differs from other ones that we've seen, for example, at Bluff Creek. Those had much bigger spikelets, these units along the inflorescence stem. This one has just a couple, looks like 10 or so flowers on each spikelet. So small flowered, few flowered sedge, one of our woodland sedges here. I might have to ask an entomologist about this one. I just noticed that right next to our other sedge, there's a sedge that's got a couple of shield bugs or something crawling on here. Just kind of stood out to me as interesting that 2 of the same species would be on the same plant. And this isn't really a season I would think is good time for foraging for pollen on this plant. So it's done its flowering, it's already moving on to fruiting. I don't know what they're interested in. Maybe they're piercing and feeding or something. So this site has its share of poison ivy as well. There's quite a bit in this crop off to the side of the trail. Some really big, luxurious leaves of poison ivy here. You can see there's a little bit of, not much in the way of lobes off to the side of those leaves. Sometimes that's the thing you might look for. Here's another in the center, another individual of poison ivy with more toothing along the margins. So I call these irregularly toothed. It's kind of unpredictable as to whether they're going to be very toothed or a little bit less. There are also here some illustrations of some newer leaves coming up. So new poison ivy leaves, not really the season for new leaves, but I guess they're expanding their territory right now. They come out a lot more waxy, sometimes reddish. And so those are some poison ivy little ones to watch out for. Some plants that are not poison ivy in here include this one. So this is a member of the bean family. So this one would always have entire margins. It has a little bit more of a tapering leaflet tip. It does have leaflets of 3. And this is one in the stick-tight group. And then another one, sometimes it's actually poison ivy leaf in the background, but in the foreground you can see there's one that's got more of a twining stem associated with it. This one's got the fun name of hog peanut. So this is Amphicarpea bracteata, bean family. This one twines around. I don't know if I've hardly ever seen flowers of this one. It's a very prolific vegetative grower where it grows, but I don't see the flowers too often. I don't often get a chance to point out the trees, mostly for the reason that we just can't get up to the parts that we would look at to identify them. I don't know how well this has come across on the video, but we'll try it anyway. So over here we've got a hickory, so you can see some compound leaves in, looks like 5s, just really broad leaflets on that one, very big leaves on the hickory. Here's another hickory over there in the background. This one in the foreground, we've got an oak with, looks like leaves that terminate in teeth, so leaf in the oak in the red oak group, a handful of those. We've got one with simple leaves with pinnate venation and teeth, and I thought I could point that one out because I have some much smaller examples here. So these are elm leaves, very kind of evenly parallel veins, 2 ranked, so the leaves come off on one side or the other of the stem. They're alternate, toothed. And I'm not usually too good at elm or any tree really on the bark. Some of them stand out to me, other ones I just need some help with. These have kind of a stringy bark to them in my experience, lightly colored. So a nice illustration here of some kind of uniform understory. The graminoid here is that few flowered sedge that I pointed out before. You can see there's kind of a sedge habit to it where it's arching over a little bit. I don't really talk about the mosses, but here's a really nice example of one of our mosses growing here. Mosses typically like kind of shady, moist habitats, and that's certainly where we're at right now. And then among those, really the next dominant understory plant is this bean family plant. I remember it as a desmodium, but it's gotten into a new genus, so I'll have to update that as on the sheet. I guess some others that are not flowering, cool to show off nonetheless. This is one type of plant we call hepatica in the buttercup family, Ranunculaceae. And hepatica leaves very distinct, so 3 big lobes. Hepatica means, it comes from the word for liver, so like hepatic disease is a liver disease. Kind of looks like a human liver. So back in the day, people thought plants were noteworthy if they looked like human organs or something like that. This one flowers very early in the year. It's already probably dispersed its fruits, so I don't see anything except for the leaves that tell us that's the species. We've been doing a little bit of animal interactions here, and there's some good examples today of leaf mining. So here's a leaf that is, it's got these squiggly tracks in there. This is an insect called a leaf miner. So this would be a larval, I don't remember what kind of insect, and you can just see it's traced in there. The mining part comes from the fact that it's doing that inside of the leaf. So in between the upper layer and the lower layer, it goes around in there and chews up what's inside. This is the biggest part. It's kind of neat. You can see the tracks getting bigger, I think, as this animal developed. So it's now a fat little insect. I can't quite tell what's going on, but there's a brown spot there at the end of this trail. That's where I would guess to look for the insect, if I was going to look for it. Here's a really lush example of one of our bed straws. A species, I guess I should say, with bigger leaves. The whorled leaves, kind of elliptic leaves, kind of an angled stem. You can even see this kind of shake in increments as I roll the square stem around. So it's not square stemmed like a mint family. This is in the coffee family, or the madder family. And just having those whorled leaves as an understory shrub, pretty good giveaway for this group. Also, if we look at the stem, a little bit prickly there. So pretty neat, common understory plant. Here's a fairly common member of the rose family, Rosaceae. We have stipules at the base of the leaves. The leaves are lobed, so here's the lobe, not compound, but then down here it's compound. So it's kind of a ratty look overall. Here's one that's definitely compound into 3 leaflets, but then sessile, so it's not on a petiole on the stem. Rose family flowers, similar to the other family, Ranunculaceae, the buttercup family. Also a little bit more diversity in rose family flowers. So we do have 5 petals, they're separate, 5 sepals, separate, lots of stamens. So those dark red colors are all the anthers there. And then lots of separate carpels also, kind of on a little bit of a spiral dome there. You're probably not going to be able to see it. Let me get in there and give it a shot. Probably a little early in the season to see it, but this is a group called Geum, the Avens. This is the Geum canadense. And in this group, the styles end up being hooked, and that helps in the fruit dispersal. I'm excited to see this one. I don't remember seeing this here before. This is one of our milkweeds, not the common milkweed. There's a milkweed you typically find in all kinds of habitats. This one I don't know that I've ever seen before, so super exciting. I knew that it was a milkweed even without looking at, say, the milky sap. These flowers are just so distinctive. So they've got 5 petals that are reflexed back. I'm sorry, sepals, 5 sepals pointed backwards. The petals are not really a noticeable part of this. They've got a strange structure. So once you get to know this, it really stands out. I knew this was milkweed right away. There's like a little pocket that holds the stamens inside. You can see there's an ant in one of these that's going to town on probably some nectar that's in there. So this pocket type of structure, or hoods, sometimes they call them, very distinctive of the milkweeds. Not all of our milkweeds have milky sap. Let's double check on this one. All right, there it is. So just break it a little bit, the sap comes out. Also similar to the other milkweeds, this one has an umbel inflorescence, so all those long pedicelled flowers all tracing back to the same place. So here's a good example of how habitat might change the phenology of a species. So we saw lots of members of this species down below in a more shaded area. I'll show you the flowers, the leaves as we saw them before. So those leaflets of 3 tapering into this long tapering leaflet tip. Down in the forest in the shaded area, we didn't see any really flowering, and this one has open flowers, so open for business. Can tell us here that we're, whoopsies, looking at a plant in the bean family, so that standard petal on top, and then 4 other petals all kind of wrapped around that middle part there. Boy, they're really just jumping off. I'm going to give it a shot to take it apart. These are a little bit tricky. So you can see the sepals down at the base fused together. Take this apart. Alright, so I took a couple petals off and exposed the keel. And then there's a little green sticking out. There we go. Okay, so I've got the petals off. This is the reproductive organs. The stamens are actually fused together and closely associated with the ovary and the style. So I don't know if I'll be able to take those apart to show you, but those are the reproductive parts hiding in that lower part of the bean family flower. Also in the background here, one that I also kind of rarely see with flowers or fruits. This is our hazel, Corylus, kind kind of a rough leaf, a little bit hairy, and toothed on the margins. This is in the birch family. Here's another good one. This is what you're seeing here is a false Solomon seal growing very closely associated with the plant I wanted to talk about. I thought I'd mention this just to kind of give you the the sense of knowing how to tell your plant species apart. So we have definitely different kinds of leaves here than we do here. So these are parallel veined sessile leaves that are alternate. And then here we've got pinnate veined leaves that are opposite, and lots of other differences as well. This is in the same family as milkweed, Apocynaceae, but it's not a milkweed. It does have a nice, we'll give our pollinator a little time to explore. A couple in there. So these bell type of flowers can have a nice stimulus where they're kind of providing a little bit of a shelter or a warm place for pollinators to hang out. And actually see quite a few just all over the place. Flowers of this species are really full of insects. Focus, my friend. There we go. So some flies here, quite loving the flowers on this species. There's a little weevil exploring around. All right, maybe we can find one of these that doesn't have an animal in it to identify. All right, so this one does have milky sap. It's in the genus Opossum. Fused petals, much different than we saw on the milkweed. For a long time, milkweed was in a different family, but recently it's been in the same family as this. They've always been closely related nonetheless. I don't know if I'll be able to dissect this out, but just the bell appearance of the flower. There's some white, I don't know if you can even tell. Sepals are actually white and small at the base of this fused petal corolla. And then this one also, as I mentioned, milky sap. So take the leaf apart and watch it drop some sap out. Here's another one that I don't see too often. Kind of excited to see this one here. This is a member of the same family as our honeysuckles, but rather different look overall. So this is a herbaceous plant, and big sepals, I should say, associated with those flowers. We have one flower still open, very exciting there. Later in the year, these make pretty big berries. Leaves are opposite and parafoliate here, so attached, two opposite leaves have an attached portion next to them. And this one's called horse gentian. I didn't know horses liked gentians, but maybe this is their style. Here's one with a fun common name. This is called Enchanter's Nightshade, and this is pretty distinctive as long as you've got the flowers. So opposite leaves, palmate venation, petioles on the leaf, flowers in a panicle, also with pedicels, and then rather fuzzy inferior ovaries, and those are going to become useful for dispersing. This is one of the plants that makes fruits with hooked hairs on them that can grab onto fur. Rather unusual for this group. This is a two-petaled flower. Actually, unusual overall. This is 2 petals, 2 sepals. It's in a group, the evening primrose family, that usually has multiples of 4. Now we're down to multiples of 2. So that in itself pretty well gives away plants of this group. So here's one that might look at first blush a lot like other plants that we have in this area. Just happen to recognize it. It's got pinnately compound leaves. This is actually a herbaceous plant, so that traces down to, let's see, that one's got a leaflet of or 7 leaflets, sorry, 5 leaflets there. A number of leaflets here, but those leaves also keep going down to here. That's a good question. Is that a leaf or a stem? What stands out to me to identify this, not under every one of these, but sometimes we have from the same rootstock a flowering stalk, in this case now a fruiting stalk, that both parts of this are giving us this whorled branching or 3-parted branching. The leaf stalk, the vegetative stalk, and also the reproductive stalk. And then the part I'm holding is definitely an umbel of multiple parts coming out. This is a family related to the carrot family. This is the same family as English ivy. This is Araliaceae, and this is a member of the genus Aralia here, going up to fruiting, and you can see the nice inferior ovaries there with perianth parts left over at the top. Here we've got a viney monocot. Don't have too many like that. This one goes by the name of greenbrier. That's what I call it anyway. You can see the parallel veins. You can see that the stem of this is behaving kind of viney. It's angled at it's sort of bending around at the top. And you can see the tendrils. The tendrils in this group, kind of curiously, are modified stipules. So you can see pairs of tendrils coming out from the bases of these leaves. This will be able to grow up the plants that it's growing around. This is another one that is dioecious, and its inflorescence is this globe, umbellate globe of flowers. And what we have here are male flowers. So you can see we've got per flower, you can see that 6-parted pattern. So 6, a multiple of 3, tells us we've got a monocot. And then you can see just at the tips of those kind of a shrivelly bit that would be the anthers that are giving away the pollen. Maybe in the same habitat we'll be able to see a female plant. So let's see if we can find it. Maybe not.